Hi students, welcome back to Chakravarthy E Classroom. Let's continue the same chapter today, time and distance. We have been doing some typical questions on time and distance for the last two sessions. In this session, we are going to discuss same question from the same chapter, but the concept here is relative speed. Let us discuss one question based on relative speed. See students, first pause the video and try to do this question by yourself. The ideal time for this question is not more than 30 to 35 seconds. Of course, beginners don't go around the timing. First, you try to get the accuracy. After that, you need to focus or concentrate on the timing. Right. After resuming the video, you try to compare your method with that of mine so that if anything new is there, you can learn some new things. Just try to learn that. Okay? Right. How to go for this one? First, read the question properly. What exactly they have given? A car is 360 meters behind a bus. Simply try to visualize that one. One car is there, one bus is there, car is 360 meters behind the bus. Then the question is, in how much time the car will be 900 meters ahead of the bus if the speeds of the car and bus are 90 and 36 kilometers per hour respectively, and they have given some timing. First, what you need to do, while reading the question only, you need to analyze that one. Now, simply represent the same data as a diagram so that your understanding will be like more than reading, isn't it? Now, how to represent this one? Simple one, students. I am taking in this way. This is the car. Alright, and this is the bus on a road. The distance between car and bus according to the question is 360 meters. Now the question is the car should be here. That means car should be 900 meters ahead of the bus. In how much time the car will reach this place is the question, isn't it? See students, here relative speed concept comes into picture. I just explain you what is the relative speed in a nutshell. In our course, in our foundation courses, I have explained the relative speed concept almost for 1 hour with the different numbers and different cases so that every student must understand that. Now, here in this session, in a nutshell, I will explain you what is relative speed. See students, before going for this example, relative speed is calculated in two ways. Suppose two objects are there. Two moving objects are there which are apart like this, and both are moving towards each other with some speeds respectively. In that case, the relative speed means you need to add up both the speeds. For example, one car is here, another car is here. One is moving at 100 kilometers per hour, other is moving at 60 kilometers per hour. Both are moving towards each other. In this case, what is the relative speed means without much thinking you must say both the speed should be added because both are moving towards each other. In the other way, one car is 100 kilometers per hour the moment is, other one is 60 kilometers per hour as it is, and both are moving in the same direction. In this case, the relative speed will become 100 kilometers per hour minus 60 kilometers per hour because both are moving in the same direction, isn't it? That is the basic concept of relative speed. Let's take a small example here. After that, we will go back to the actual question. Let's take in the same way, suppose this is a car, alright, and this is a bus. The distance between these two on a main road is 90 kilometers. Let us imagine this one. Now, everybody will understand what is the relative speed concept in the same direction. Alright, so then this car speed they have given 90 kilometers per hour. Okay. Now, before going for the relative speed, first try to understand the basic concept. It is purely for the beginners. What is the basic concept here? Suppose car speed is 90 kilometers per hour and the bus is not moving. This is not moving. First take this example, then we go for the relative speed. Okay, the bus is not moving. It is at the stationary position only. Now you tell me, speed of the car is 90 kilometers per hour. The distance between car and bus is 90 kilometers on a main road. And now the question is, when the car is going to reach the bus? Without much thinking, within 1 second you can give the answer as it takes 1 hour. Because the car has to cover 90 kilometers to reach the bus with the speed of 90 kilometers per hour. In 1 hour, car is going to catch the bus, isn't it? Now, let us extend that one a little further. Now, let us take in this way. Bus is also moving with the speed of 80 kilometers per hour, for example. Okay, now the speed of the car is 90 kilometers per hour. Bus is 80 kilometers per hour. The distance between car and bus is 90 kilometers. And let us imagine in this way, both have started at the same time. For example, at 7 a.m. Now, when the car is going to catch the bus is the question. Now, how to go for this one, students? Here, you need to use the same formula, that is, I need the time. Time is equal to distance by speed, isn't it? But remember, students, here the speed will become the relative speed, remember. And the distance will become the lead distance. I'll tell you what is lead distance, what is relative speed. Now, come back to this one, students. Previously, for the simple question, you answered that in 1 hour car can catch the bus because bus is not moving. But in this case, students, observe carefully, in 1 hour, the distance between car and bus will be reduced by only 10 kilometers. Yes or no? In 1 hour, car is moving at 90 kilometers per hour. Bus is moving at 80 kilometers per hour. So, in 1 hour, the distance between car and bus will be reduced by only 10 kilometers. Because in 1 hour, car covers 90 kilometers minus bus covers 80 kilometers. Now, the distance between these two is 10 kilometers will be reduced. That's it. That will be reduced. If you speak in terms of speed, the relative speed will become 90 kilometers per hour minus 80 kilometers per hour. The relative speed will become 10 kilometers per hour because both are moving in the same direction. Now you understood the concept. Now you tell me in how much time the car is going to catch the bus. To catch the bus, car has to cover 90 kilometers. This 90 kilometers is called the lead distance. If the bus is at the stationary position, 90 kilometers is called, how it will be called? Normally distance only. But when both are moving, for car, 90 kilometers is the lead distance. It has to cover this 90 kilometers in this case to catch the bus. Now, the lead distance is 90 kilometers divided by relative speed is only 10 kilometers per hour. Because one is moving at 90, the other one is moving at 80. To catch the slower speed one, the speed will become relative speed, that is 10 kilometers per hour. To cover this 90 kilometers, 10 kilometers per hour, how much time it would be taking? Obviously 9 hours. In 9 hours, car is going to catch the bus. When would the car is going to catch the bus? 7 a.m. plus 9 hours is my answer. Isn't it? So, this is called the relative speed. Always remember, students, both are in the movement, both are in motion, both are in the same direction. Speed should be, we have to use the subtraction there, that is 90 minus 80. When both are in the same direction, you have to add up the speeds. This is the basic concept. I am going to use the same concept to solve this question. See, students, this explanation is for the beginners. If you are an advanced student doing advanced level question, take it as a brush up for you. Okay, right. So now let us apply the same concept, relative speed concept here. How to go for this? Same thing, I need to find out the timing here. Time is equal to distance by speed. The distance is lead distance, speed is relative speed. Now here the lead distance is how much distance the car has to cover to be 900 meters ahead of the bus. That is 360 plus 900, that is 1260 meters. Okay, and what is the relative speed here? The car speed is 90 kilometers per hour and speed of the bus is how much they have given, that is 36 kilometers per hour. And obviously the relative speed is 90 minus 36, 54 kilometers per hour. But one thing you have to observe here, you must be careful about the units, students. Here this is in meters, but it is in kilometers per hour. And what form I have to give the answer, in which unit I have to give the answer, to go for that one, go for the options. In the options you see, this is 90 seconds, 84 seconds, 120 seconds and data inadequate. So this is based on the seconds. So now, since I need to get the answer in seconds, convert this 54 kilometers per hour to meters per second. Why meters per second? Because one of the quantities here given, that is in meters, and they are asking the answer in seconds. I need to convert that one to meters per second here. How to convert from kilometer per hour to meters per second? In the basic classes we have learned that one, that is into 5 by 18. Why multiplied by 5 by 18? I have given the reason for that one. Now if I go and explain that one, it will become very lengthy here. In our foundation classes we have discussed why it is 5 by 18 or 18 by 5. Okay, so here I need to multiply this 54 with 5 by 18. So this is 18 3 times and 15 meters per second. Alright, now to get the answer, substitute these values in the formula. I'll write here. So distance, I need to find out the time here. Time is equal to distance 1260 meters divided by the time is 15 meters per second. Just go for the simplification. This is 15 8 times. 126 is remainder and 15 fours, 84 seconds is the answer. Because this is meters and this is meters per second and my answer is seconds. So in option number we have rounded it off. In option B we have got the answer. Hope you understood this one. Generally this type of questions are expected in RRB Group D, then Railways NTPC exam or SSC CGL. In that type of examinations you can expect questions of this difficulty level. But for other exams like bank clerks or POs or any other competitive examination which is of more difficulty level, you can get the questions based on relative speed but in the other format. Okay, anyway students, thank you so much.